All right, let me introduce Dr. Stephanie Getty. Excuse me? Oh, okay. Dr. Stephanie Getty is serving as the acting director of the Science Exploration Directorate at NASA Goddard. Her research interests are in situ planetary exploration, particularly in the pursuit of understanding the origin and evolution of past and present habitable environments in our solar system. She is currently serving as Deputy Principal Investigator of the Da Vinci mission to Venus. She's also a member of the ExoMars Rover Mars Organic Molecular Analyzer Science Team. This is very concise. I just have a couple of personal comments. Stephanie has had a remarkable journey through Goddard. She came here 25 years, and she actually came into the materials engineering branch. I think I remember the first week she was here, she was asked to write a DEF proposal. Really good. I remember she said, how do we do this? And she did it. She won it in the areas of technology development for carbon nanotubes and applying them to instrumentation. And then she began later. At one point, she won the Goddard Innovator of the Year Award. Yes, quite prestigious for her development. I think she probably had patents along the way. And then she was working with the scientists in the mass spectrometer group code 699. So then she went over there. And here you go, she worked in instrumentation, now she's the leader of science at Goddard. So welcome, Stephanie.
All right, for the embellished bio there, Carl, that was nice. How is this audio working for everyone? Is it good? Okay, I'll try to keep it at a good distance. I also want to thank Carl for that lunch he took me out to all those years ago when I was in early career. Just an example of how important mentoring has been to my own career and how important this organization continues to be. I'm really pleased to be with you here today, and really happy to see so many folks that I consider to be mentors have been mentors to me along the way, so thank you. And I want to also acknowledge Marlo Maddox, who is Acting Deputy Director of Sciences and Exploration Directorate. Plus one today. Thank you, Marlo, for joining. And if you leave soon, it's not because I'm doing a bad job up here, I think. It's because you have a meeting to get to. So, all right. Well, I think that we've been through in science at Goddard, as well as the center and the agency. We've been through a year plus of transformation, but I'm really pleased to say that science and analysis of the space environment has been core to Goddard's identity from its very beginning, and it continues to be. So I want to highlight for you that we really see ourselves as being the drivers behind progress in the area of science on the civil space side. We continue to have a team that is really dedicated to bringing the best of their abilities to the work that we have to do at Goddard every day, and I'm really privileged to be, in a leadership position for the SCD. So what we did most recently, oh look, I over-animated it. Wonderful. What we did most recently was to host an All Systems Go ignition event for center-wide for NASA Goddard. And what I want to present to you today is some of the materials that are really intended to connect the portfolio, the strong portfolio of work that we continue to implement at Goddard to areas that reflect our importance and our forward-looking relevance to the agency and to the nation. So I don't know if you've heard about the three areas of kind of priority areas that our Acting Center Director Cynthia Simmons refers to regularly. But these three areas, Moon to Mars and exploration, security for the nation, and protecting the planet are three ways to really connect the work, the really sophisticated work that we do at Goddard, to the interests of the general public, and to really convey, make those connections to how, science at Goddard and the way that we implement science through our missions really touches on everyday life and benefits humanity every day. So, so when we think about getting, astronauts and robotic missions to the moon, onward to Mars, we think about how the decades of scientific investigation really underpin the success of the ultimate success of that mission, the ultimate safety of those astronauts. That means from the moment that Artemis II left the launch pad and traveled through the Earth's atmosphere, through Earth weather, through the space weather environment, and to the lunar environment. Science really underpinned the safety of that crew along the way. I know that you heard from Monty Polkinen a couple weeks ago or a month ago, and he talked a bit about the Space Weather Analysis Office. So I won't dwell on that, but I'll share, some of the broader stories about how Goddard Science supported Artemis II mission. Security for the nation, we provide trusted insights through our data products and provide those insights, across the ecosystem for proper decision-making, informed decision-making. And that really touches on advancing our national posture, advancing the assets that are so important to the broader ecosystem. And then, thirdly, protecting the planet, the way that we conduct observations, connect those measurements to models, and then enable our scientists and the community to make predictions that really allow us to protect people and communities across our own planet. This is just a little bit of background. It continues to be an active science fleet. So I know that we went through some periods. Of uncertainty and how the continuation of some of these missions. We're really gratified to say that from our implementing missions to the operating missions, the project scientist role, the research underpinning those efforts all continue by and large to be healthy. Let me go into a little bit more detail about the Artemis II science. Artemis II, of course, launched from Kennedy April 1st. That was my first launch to watch a launch from Banana Creek viewing area. It was a real privilege to be sandwiched between Sarah Noble, who is our lunar scientist with Exploration Office, and then Lindsay Hayes, who's the Mars Exploration Program scientist. Between Noon and Mars, two wonderful women I love. And we saw that rocket launch, and it was incredible. And then the excitement just continued for the 10 days of that mission. I'll highlight, this is, my turn. This is down at Johnson Space Center. You may have followed along. I think the access to the science operations during the course of that mission was unprecedented. You could really follow along with the work that was being done, not only on console. This is Kelsey Young. She's a scientist with us at Goddard. She's amazing. And it's really her vision that enabled science to be so integral to this mission. She built the foundations through very close working relationships with her colleagues at Johnson Space Center, and then brought the lunar expertise at Goddard to bear on this mission. So very exciting to see, and to hear Kelsey exchange with the astronauts, the crew, during the flyby of the moon. Okay, I don't have a clicker, so I have to go back and forth. To complement the flight control room where the science operations lead was, Kelsey, this is the science evaluation room. This is Marie Henderson, Goddard scientist. This is Maria, good, I'm being recorded. another graduate scientist who's incredible. And you can just see just how engaged, all of that preparation. Maria, thanks. Sorry, Maria. All of that preparation in the back room to, and seeing those new observations through the crew's eyes. It's just that vision carried through to this new age of being able to integrate human observation with, scientific hypotheses and goals to make entirely new observations of the moon. And that started years ago. Right, so here are Christina and Victor and Marie here in the background. That started with training of the astronauts, not only in the classroom, training them about lunar geology and the features that we recognize from the maps that Lunar Reconnaissance Orbiter has been making for over 16 years now, but also going out into lunar analog environments on Earth and taking the crews out to explore on the surface some of the formations that are analogous to what they would see from the flyby of the moon. So a lot of training that is, paving the way for our next landed Artemis missions that are coming up in 2028. So Project Science at Goddard, not only for Artemis II, but also for Artemis III, which you may have heard was imagined as the next landed mission, but now will be a low Earth orbit mission to buy down some risk. Good idea. We will have the project scientists leading that. Barbara Cohen will be that. Will play that role for Artemis III, and then Noah Petro will be the project scientist, also at Goddard, for overseeing those landed missions. And a lot of the preparation for the interaction between science hypotheses, science insights, and that geologic preparation will serve that crew well as they go to explore the south polar regions of the moon. In addition, South Polar region very hazardous in many ways, not only radiation and that dust, but the low illumination conditions. And so understanding the traversable, is that a word, pathways between the lit regions in the South Pole, not an easy task, and that's really informed, as this mission was, really informed by LRO data and then the visualization that's enabled after orbiting the moon for so long. I mentioned LRO data and visualization, and here's an example. So this is a visualization of the moon during the flyby compared to the actual observations taken on an Artemis II photograph. And you can see the similarities and some, measurable differences. And so it reinforces why we do go, of course, but also the preparation that was really enabled by being able to visualize what the astronauts were going to see once they got there, so that they felt prepared and they could really focus on their observations, having a good foundation under them. Right, and this is just an example. I won't go through all of this because I think I've already been talking. I'll say that I was fortunate enough to get those daily reports from Kelsey and from the Space Weather Analysis Office as well on how the mission was going, and it was really gratifying to see that final preliminary report that really spanned across the sciences. So I've talked a lot about the lunar geology, but that particular April 1st launch date enabled their crew to observe an eclipse, and that brought heliophysics into the observations. And there are even reports, on the astrophysics side of the astronauts, conducting meaningful observations of out in space we're looking. Artemis is a great example of not only the interaction between crew and robotic missions, but also across our science disciplines. So we, in SED, and if you probably know that we have 4 science divisions: Earth Science, Astrophysics, Heliophysics, and Solar System Exploration, or planetary. The connections between planetary and heliophysics have been only strengthened, not only through the activities associated with this very well orchestrated Artemis II mission, but we've also established a suite of physical space where they sit together, the leaders from the different aspects of the Artemis program as it's expressed at Goddard Science. They sit together now and they're building those relationships. They're really going to bear out as we continue through the Artemis campaign. So you did hear from Auntie on the new to Mars Space Weather Analysis Office that really connects to the state-of-the-art modeling capabilities that draw from observations across the heliophysics suite to be able to make predictions about the radiation environment, the activity, the solar activity, energetic events that may be heading their way as our crews and our robotic assets, NASA robotic assets, explore through the solar system. They also are incredible human beings behind this effort that were stationed at Johnson and also at Goddard. In fact, the team at Goddard conducted 24-hour shifts for the duration of the Artemis II mission. I think you did hear that from Monty, but just an incredible environment, supportive environment to make sure that they're monitoring the activity from the sun and able to communicate regularly to the Space Radiation Analysis Group at Johnson Space Center to keep those astronauts safe. They play a regular role, a daily role, and a regular communication. Oh, are we doing questions? Oh, yeah.
And I heard about this before.
Yeah.
The sun.
There was some activity that they were monitoring and analyzing for the particle radiation compared to the hazardous levels, but nothing that would have caused a reaction or required the crew to take any special precautions. Yeah, good question. Okay, so those are just a couple. Artemis II is just one example of how Goddard is playing a role in this key area of exploration, Moon to Mars. Some other examples include our deployable lunar environmental monitoring suite, which will be deployed to the surface through interactions with astronauts. That's a self-contained unit that's capable of making scientific observations and surviving the lunar night. Of course, the day is 2 weeks long, and the night is 2 weeks long, and so surviving through that period of darkness is no small feat, and so Len's cracked that puzzle, and it really paves the way for deployable scientific measurements from the surface going forward. And then onward to Mars, of course, you heard from Carl. MOMA is near and dear to my heart. I was the calibration lead for that instrument. And that instrument has been ready to go for quite a while, and it will see the surface of Mars. It'll launch in 2028 on an international mission. That's the Rosalind Franklin rover. It will go and drill into an entirely new region of Mars, 2 meters deep, beyond the crust of radiation damage from galactic cosmic rays and other sources of radiation, and maybe reveal new limits, new understanding of habitability on the subsurface of Mars. Very exciting. The CLIPS, I want to mention the Commercial Lunar Payload Services. Maria Banks, whose name I remember all the time, is one of the project scientists for the CLIPS program. CLIPS is a really risk-forward program that allows you to place meaningful payloads on these landed, these commercially provided landers, and really ramping up. The philosophy is the more you fly these things, the more you learn, and the higher your success rates will be as you proceed. And so we're going to see that really accelerate. We saw that out of Jared Isaacman's ignition day the week before the Artemis II launch. If you haven't watched some of those presentations, science was front and center for that, and really this notion of accelerating time to science has the Moon and Mars in central to that philosophy, and it's an exciting time. So I think we heard at Ignition Day that, up to maybe 30 CLIPS payloads will be, targeting the lunar surface over the next 3 or so years. So that is definitely an acceleration and a great opportunity across the community to support lunar science and exploration. Turning now to security for the nation, I talked about this a little bit, but I'll highlight here a couple of examples of where Goddard is really, at the forefront of the types of technologies and ambitions that NASA is perfectly suited to push forward in exploration of the solar system and deep space. That technological scientific forefront for the United States is really enabled by missions like Roman Space Telescope. You heard that it's in the clean room for now, but pretty soon it'll be loaded up and shipped off out of, on a barge, correct? In June 10th to June 13th timeframe. And it's set to launch. So that team is through the development cycle, a really close-knit team, a really expert team. The project scientist team is really amazing. This will take us. Roman, of course, will take us into a new era for astronomical observations. It takes us from directed, pointed observations of astrophysical objects into a survey mode. Over the 5 years, nominal operating period of Roman, it'll generate 20 petabytes of data, which is, to date has only been experienced in the earth science community. And so very excited for this team to generate huge swaths of the sky at regular intervals, start to unlock some of those dynamic scientific processes or energetic processes that are happening out in our universe. We're not getting tired of hearing this, right? Ahead of schedule and under budget. So the center is just so proud to bring this telescope into space as the next great observatory. That's enabled, of course, by detector plane that is 100 times larger than the Hubble Space Telescope, and also leveraging good collaborations across the agency, demonstrating a coronagraph that will allow real dynamic dynamic range for observations of this type, and the community is really excited and geared up for that. And that will pave the way for the next great observatory, the Habitable Worlds Observatory, which turns its focus to really searching for exoplanets outside of our own solar system that may harbor signs of life. I think you've probably heard about this. This continues to build on the early science concept studies that went in, and now the technology maturation phase is underway. And so that'll take lessons learned from previous builds to really invest in those technologies that will enable the breakthrough science in a way that is very intentional and very exciting to think about the types of more Earth-like habitable planets that will be observable with this capability by blocking out that center star and being able to do direct imaging of those candidate habitable exoplanets. Really exciting for Goddard to be at the forefront of that, and through partnerships as well. Let me describe a bit about Dragonfly. Dragonfly will be our next delivery. We'll deliver the central payload elements to the Applied Physics Lab, who is leading the mission. This is a verticraft. It's an octocopter that will fly out to the outer solar system to this moon called Titan. It's a moon of Saturn. Titan is organic rich, so you see before. I think it was good, but good for movement. But I'm getting it right. These dunes out here have, a hydrocarbon composition to them. There's likely water ice rocks and water ice under the surface. It's got a thick atmosphere. It's got substantial gravity. Some people consider it to be a pretty good analog for an early Earth before oxygenation took hold. And so a really fascinating and member cryogenic, 92 Kelvin or so at the surface, but an end member for what habitable environments look like within our own solar system. And it's a diverse place with dunes and rocky fields and boulders. And so the best way to do that, to explore an environment like that with a thick atmosphere, the team tells me, is to load all of your instruments onto this rotorcraft that will visit across multiple diverse landing locations and sample the surface in those locations to look for that organic surface composition. Some of you may know that Titan also has a methanological cycle, not a hydrological cycle, but it rains methane and ethane and forms persistent hydrocarbon lakes in the polar region. So really just a fascinating world. This we don't expect this rotorcraft to get rained on while it's out there, but certainly it will explore the diversity of environments at Titan. And Goddard is building the DRAMS instrument, Dragonfly Mass Spectrometer instrument, and is managing the sample acquisition system as well. In fact, this team just welcomed the gas chromatograph subsystem from our partners over in France at Latmos, so our Kiness partners, that was so successful on the sample analysis of Mars instrument suite, which is still kicking around Gale Crater on Mars. And climbing Mount Sharp at Central Mountain. So a lot of the chemical analyses that we're proving out on Mars are now being translated to the outer solar system. So it's just such a cool capability. We'll look forward to that mission launching. And then also near and dear to my heart is Da Vinci. So from the coldest reaches of the outer solar system to our hot neighbor, Venus, inward to the sun. Venus is the other extreme of habitability, right? So from potentially early Earth to potentially what happens if a previously habitable environment turns bad. You end up with, with a surface pressure of 90 times that of Earth. You end up with basaltic lava formations across 80% of the surface. You end up with temperatures, of close to 500 Celsius at the surface, and these really strong winds that you have to pass through, sulfuric acid clouds that you have to endure if you're going to probe the transect of the atmosphere, which is what Da Vinci will do. So you may know that there were Pioneer Venus probes that were sent into the atmosphere of Venus back in 1978. The deep atmosphere, those measurements didn't perform to expectations, and so the deep atmosphere of Venus continues to be largely a mystery to us, and you can't tell the story of the history of Venus and whether it ever was Earth-like in the past without understanding, the full story of the composition and the structure of that atmosphere. So that's the question that Da Vinci will target, and it will do that by building this submarine of sorts to kind of delve into and take regular measurements or regular intervals as it descends through the atmosphere of Venus. And there's a mass spectrometer on here. There's a tunable laser spectrometer from JPL. It's another good example of collaborations across the agency. And it'll measure the physical properties as well. And all of those will tie together to a complete understanding of the atmosphere of Venus and whether it was more Earth-like in the past. So very exciting. All right. And let me turn a little bit to some of the examples in our current implementing portfolio at Goddard that also speak to this broader theme of security for the nation. So not only, that ambitious engineering and technology development, but mentioned swiftly reboost mission. Very excited to see that commercial partner and the boost element from Catalyst get through integration and test, environmental testing, and get ready to launch. Swift, probably knew Neil Garrels. I don't know if his daughter was an intern with me back in my early days, so that was really great to have Emily working in the labs with me in my King's group back in the day. And so I think fondly of Swift as well, but it's also a workhorse when you're looking at time domain astrophysics. And so it's important to keep that thing in orbit, even if the sun is throwing solar activity that's interacting and exciting the Earth's atmosphere and trying to bring that spacecraft in. We boost it to a higher orbit and we'll have a lot more life in it to come. Also, just briefly mention Athena, which is another ESA partnership to explore other aspects of astrophysical observations. We mentioned habitable worlds, and then a couple of other, really enabling technologies and data capabilities, analytical capabilities that promote security for the nation. And of course, our operating missions continue to produce a really important backdrop of data that is analyzed and validated and then processed for the broader community. And speaking of which, protecting the planet and understanding our home planet and the Earth system across the different dimensions of our planet is core to the work that Goddard does. And I'm so pleased that through the Earth System Explorers program, we were selected to implement the EDGE mission, which is a next generation LiDAR mission, which will look at the canopy, tree canopy of the Earth, as well as exploring the ice coverage in the polar regions of our Earth. So both of these observations really critical across the sectors of how our planet works and how our societies across the planet work as well. And so really a far-reaching new mission that will map the planet and look at through laser altimetry. And not only did we win EDGE, but we won Strive in the same competition, which is incredible. So 2 new Earth science missions through Earth Systems Explorers. And the second one is that I'll mention here is Strive. So this is the stratosphere-troposphere response using infrared vertically resolved light explorer. I mean, that is just the dream acronym. It's amazing. But really focused on the mid to upper atmosphere of the Earth, this region of the atmosphere, looking at radiometry normally in nadir, looking at like a swath configuration, but also new technology looking laterally at the really important dynamics at this stratosphere-troposphere region that really has, improved understanding of this physics, has really critical connections to across a range of sectors and a range of everyday life. So we're really excited for these teams to get started. Oops, what did I do? In terms of kind of advancing new capabilities, I also want to highlight, through collaboration with engineering technology directorate, working very closely to really optimize how we're using our resources. And so through this new initiative called text to spaceship, really using new AI/ML and new generative design capabilities to lightweight the elements and really, optimize the systems that we build. And we just see, tremendous potential to, again, accelerate time to science through these new tools that we're putting into practice. And again, I just mentioned Ed can Strive, but we have other efforts initiating to really understand all the different aspects of the Earth system. That includes the transition from the Earth atmosphere through the ionosphere, thermosphere, and mesosphere, that really important transition region from the Earth atmosphere to space. And GBC Trailblazer is a really critical element of our space weather fleet going forward, and that is an implementation as well. That's an example of where we're going to meet the moment, and we're going to be delivering that on unprecedented time scale over the next couple of years. And none of this would be possible without that integrated modeling that really connects between the different spheres, the different processes that play on the Earth, integrating those and being able to produce really sophisticated understanding and predictive capabilities of how our planet works. Also, under this heading is planetary defense. So this is the study of small bodies that could be that could pose threats to as impactors to the Earth, and we have and that's an intersection between kind of our Earth knowledge, our near space knowledge, and the small body asteroid and comet capability that we have at Goddard, and that'll be an area of growth for us as well. All right, so that's a little bit of a tour of what we're working on now and how we're making life better every day here on our planet. So I appreciate your attention. Happy to take any questions.
So last week they were talking about a lot of training and all these science. Did they get a problem? We have to
Good question. So the end of life for the A-train for Aqua, Aura, and Terra is really currently being determined by a combination of programmatic and lifetime parameters. So they're still operating for us. We continue to make observations with those according to appropriations law, and we'll continue to to follow those appropriations and directions from the agency. Yeah. I don't have necessarily any news to share with you on that. Our posture right now is that it's not part of the appropriating portfolio and certainly not part of the work that Goddard is contributing right now. We do have capabilities, of course. We welcomed the OSIRIS-REx sample return capsule back home in September of 2024, and those samples, were analyzed within our astrobiology analytical laboratory and distributed to labs across the world. And so there's good planning to leverage and good thought to leverage for future sample return missions, not only in Goddard, but through all those partnerships across kind of the world-class set of laboratories. Also put into practice for the INSA program. I don't remember what INSA stands for, but Apollo 17 samples were stored under vacuum since they were collected and they were recently opened. And so similar kind of sample analysis infrastructure was put into place for doing modern analyses on those old samples. So we would have the opportunity, right, to make really incredible discoveries on return samples from Mars, but we'll have to follow, what happens with that program. Right now, we're doing active work on it. Yeah. Oh, I'm sorry. Oh, hello. Good question. So, so in the spirit of kind of accelerating time to science and thinking in a disaggregated way, like thinking about how to use lower cost, commercially available platforms to accelerate science and provide a good campaign for how to build out that capability. GDC Trailblazer will be a single spacecraft that will be shortly followed in a campaign that we're currently working on designing to build up that constellation. Yeah, I think it's pre-decisional, so I probably can't talk to it in this forum, but I'll say that the need to make distributed measurements of that critical ITM region of the upper atmosphere is recognized, right? The scientific value of that is recognized.
How much of your organization is working on habitable world observatory?
Oh, in like a fraction of the organization working on habitable worlds. Within the SCD, we have a solid project science team that is currently kind of managing some of the technology maturation efforts that include putting out awards to the external community to build up some of that hardware maturation. So they're working on that, and they continue to work with the outside community. I don't know what number I don't know what number of scientists we have working on Hab Worlds right now. It'll continue to get more and more attention as we deliver Ronin. And then in the interim, it's really complemented by the more holistic view on how you do how you build up exoplanetary science capabilities to prepare for habitable worlds. So it won't be limited just to that program element funding. Will be complemented by science that we do not only in astrophysics but also in planetary science to understand the characteristics of what makes a planet habitable. Yeah. Oh my God! Yes. Oh, he's in another meeting. No, I appreciate that. Yeah, please. Oh, any more questions? Okay, well, yeah, happy to come back anytime. Or you guys, we'll keep you informed of seminars that we're hosting. We're putting a colloquium series back in place, starting with. In fact, it's tomorrow. Starting tomorrow, but it'll be on a regular basis. We'll have colloquia back in place again. So hope to see you around Goddard, and thanks for having me.